Can I start, Mr. Patrick?
Yes, you can start now. Go ahead. Thank you very much.
All right, good morning, everybody. Hope we had the
Kindly put it on slideshow. Let it be bigger. Sorry about that.
Oh, okay. Yeah. So yeah, is it better now? Okay, so good morning, everybody. Hope we had a nice rest. So today we'll be talking about data mining. Yeah, so data mining is a very vital concept in data science and machine learning.
Your camera, if it's convenient for you. Thank you very much.
We're talking about data mining. It's a very important concept in data science and machine learning in general. So when we talk about mining, generally we want to talk about processes that involve getting maybe a particular material in the midst of other materials. So for instance, in gold mining, for instance, engineers have to get gold from very unattractive substances. They're always looking dusty, filthy, and all of that. And when you subject them to purification processes, we have shining gold. So we subject the materials to heat to remove impurities and other things that are not necessary. Then you get the purified gold. So for other mining processes like diamond, it's also the same thing. So similarly for data mining, it's actually a similar process. So when we talk about data mining, you want to get useful information in the midst of a large data set. So for instance, when you are working on a data set, maybe to predict if maybe a particular company will thrive in a particular area, let's say a restaurant, for instance. You want to know if a restaurant will thrive in a particular area. So at times things like maybe the favorite color of the people living there may not pay you. It's not very useful. Even though if you have access to that information, it might be useful to something else, maybe a fashion firm, for instance. So it is useful to someone else, but it's not particularly useful to a restaurant, for instance. So you probably be looking at maybe good roads, accessibility to the restaurant. Is there somewhere customers can maybe can park their vehicle, electricity, do they have electricity in that area? You might want to look at, okay, in case electricity is not so available, the location of the nearest filling station, and all of that. You factor all of that before moving to that particular area. But for other businesses, other things like that may not really matter. So when we talk about data mining, we are not only talking about the extraction of the information. It involves other processes like the cleaning of the data, integration, data transformation, data mining, pattern evaluation, and data presentation. So usually the goal of mining data is you want to be able to make a prediction. You want to be able to discover patterns or discover trends in your data to help you make an informed decision about whatever you're trying to do. So for instance, you are trying to move to a location, a restaurant. So when you've done all your data, you've done all the analysis, the prediction you want to make is, okay, in the next 5 years, will I be able to stay here? Will my business thrive in this particular area, or it will not? Or is there anything I can do to make sure it thrives? Then data presentation in a form that is understandable to maybe whoever you are presenting it for, or wherever you are showing, for instance. So once all the processes are over, we're able to use information in many applications, such as fraud detection, market analysis, product control, science exploration. So for instance, in fraud detection, there are usually patterns. So for instance, you are trying to maybe check in fraud detection, you might be able to look at the kind of messages that come in, repetition, spams. So those things help in detecting fraud or the manner of the conversation, you'll be able to have an algorithm that can, okay, this is most likely a fraud text or a spam text, or it will lead you to a maybe malicious site or something like that. So yeah, so this picture shows basically everything about data mining. You get your data, the man on the is that the ladder now, pouring out data into the machine, then the prediction and the analysis is seen on the other end, then the machine itself is what you would call the entire processor, for instance. So there are several steps we take in data mining. So for the first step, we want to talk about data selection. So selecting the right data is always very important in data analysis. If you don't make use of the right data, you will probably get a bad prediction that will probably not be useful to you. Like I illustrated earlier, someone that is trying to move to a restaurant may not really find the kind of clothes or the color of clothes or the type of shoes people wear or the kind of clothes people like in that particular area or in that particular region. So if you want to leverage on that kind of information, you probably not be able to make a valid prediction. But selecting the right data always gives the right results. So that's the very first step in selecting data. So when you have data, you need to, you're trying to build something, trying to work on a particular task. You need the right sets of data to carry out your tasks. Then the next step is, okay, after you've selected the data, you need to clean up the data, almost like when you are purifying code, for instance. So in cleaning data, we remove noise. So when we talk about noise, we talk about maybe outliers, we talk about maybe missing values, for instance. So when you are dealing with missing values, you want to know, do I want to eradicate all the missing values from the data, clear out all the rows that have missing values, or do I want to maybe put in a mean? If it's in figures, should I give it a mean? Should I or pass in the most frequent occurrence into that particular point? So it varies depending on the kind of data you are working with. Most times you may not want to just clear out all the missing values. At times you might want to maybe, if it's maybe something like income, for instance, you are trying to calculate maybe you are doing an analysis on maybe the how much people spend over a year for 1,000 people, then analysis that will predict whether those people will be happy in the next 2 years. So at times you may not have all the information about the particular person, maybe like how much he spends. So at times getting rid of that person may not necessarily be the best idea. You might want to put in the average. Okay, so on the average out of everybody, we have maybe an average of maybe 1 million per person. So you might want to pass in 1 million for every other person or that has a missing value. Or if, for instance, a particular figure pops up the most, let's say out of 1,000 samples, we have people spending maybe 250,000 per month in maybe over 500 times. So you might want to pass that in, estimating that, okay, more people spend between this range. So it is likely that the missing values can accept this value. So there are different techniques we use to clean up the data. Then at times the format of the data may not be so great for you to do analysis. So part of cleaning might be that you want to transform it to a format that is more conducive for your analysis. So the next step is data integration. Now, in working with data, at times you might need to combine data from different sources to make a conclusion. So at times maybe you are a person that deals with maybe a large firm, for instance. Let's say a large firm, you have e-commerce, you have the customer service, you have maybe the accounting department and all of that. So at times you might want to pull information, maybe you're trying to work on maybe do an analysis on a particular product, for instance. So you might want to get information from the customer care team to give you maybe some information about the customers or the buyers of that product or the users of that product more precisely. So how the product was used. So that might work in maybe the medical field, for instance. You are trying to check the effectiveness of a drug or the effectiveness of a treatment procedure. So you might want to get information about your clients, for instance, their age, how frequent they eat, their weight, their height, and if those factors affect the the rate at which the drug works or its efficiency. So those things come into play. So at times, getting things like maybe the age, the weight, the height, and all those things. At times, then combining it to maybe the efficiency. At times, you are getting data or information in different formats. So what you want to do is to pull them together to get a unified kind of uniform information, whereby you can compare those values and make correlations of those values in a particular system. So at times, if you're having numbers in different units, let's say, for instance, numbers in different units, you want to put them together to a particular point so that you can compare them together. So another important thing is data transformation. So yeah, so I already spoke slightly about it in data integration. So in data transformation, you want to combine structured and unstructured data for analysis. So it's one thing that happens when, particularly with data integration. So one data is structured, one is unstructured, but they are both important. So you want to be able to combine them. You want to be able to make use of them. So it's always easier when they are homogeneous, that is, when they are all the same. They have a particular kind of, okay, let me use this instance in, for instance, you are working with, maybe you're trying to do an analysis on students, for instance, and you want to do a correlation with maybe the score over 100, their grades over 100, and how much time they study. Now, so the study hours, probably be getting numbers like maybe 5 hours per week, 10 hours, 12 hours, and maybe then at most maybe 20 hours, a student that reads a lot. Then you're having scores around 100, 90, 95. The distance between those two values are too large, for instance. So if you're trying to pull that into a graph, in scaling it, it might be a problem. So what you can do is to transform those figures. Okay, you have 100 and you have numbers in 10 to 20. What you can do is break them down, transform them so that all the values, both the grade and the study hours, are maybe between 0 and 5. And so you are able to scale your graph and it looks more orderly. So when you plot something like that on a graph, your graph looks more organized. Okay, it's understandable. But when it's the other way around, it might look all over the place, scattered. It's not very easy to understand. So that's where data transformation comes in. You want to make sure all your data is homogeneous. It's easy to carry out analysis on them. So for data mining, finally, is that okay, after you've processed all your information, you've done the cleaning, you've gotten rid of outliers, you've gotten rid of anomalies and all of that, you now want to mine. Okay, so what it means is that we're analyzing the data, we are finding patterns. So your data is already in the form that is workable with. So the next thing you want to do is, okay, is there a pattern to what I have done? Are there correlations? Are there anomalies? So, okay, is there a pattern? Is there a trend increasing, a positive correlation or a negative correlation? Or if, for instance, what you got does not even match at all, there's no correlation between two variables that you are comparing, it can also be a result that you found out that, oh, okay, based on maybe if it happens maybe in science a lot. People say when you eat this happens to you, then you do a research, you carry it out. Okay, and at the end of the day, you're telling people that there is no correlation between eating eggs and growing tall at the age of from 25, or someone that wants to get taller, or there is no correlation between eating beans and getting taller. It's also a result. And at times it can be a negative correlation that people that ate less beans grew taller than people that ate more beans. So all of that comes into play in data mining. You are finding patterns, you're trying to discover a trend from everything you have done. And this is very important because when you have, at times you may not be able to do those things yourself. You might want to rely on maybe a machine learning algorithm that was probably built by someone else, or it's inbuilt to whatever software you are using. The importance of cleaning and making sure the data is well processed is that if you don't do that and you just feed the algorithm information like that, the algorithm might try its best to find out, make a pattern out of where there's no pattern. It just gets everything and just trying to make a pattern, data is not cleaned, is bumping into a lot of missing values. Most times you end up getting wrong results. So when the data has been properly cleaned and you pass in a machine learning algorithm to predict and find out patterns for you, what happens is you get a cleaner result, you have a more accurate result. So it makes things a whole lot easier before coming to the data mining process where you find the patterns or you find your correlation and all of that. So yeah, next thing is the pattern evaluation. So the extracted data patterns are evaluated, recognized according to the interestingness. So what happens is, okay, you found out there is a pattern. There is no correlation between beans and getting taller, for instance. Okay, so that's the pattern you have gotten. Now there's an evaluation. So you want to check whether there are maybe other factors that affected the results. No factors. So you can decide that people can eat beans. You've evaluated your data. People already know, okay, this is what has happened. You are evaluating the results. So you are telling people, okay, based on these results, then you can do this or you can't do that, or this is allowed, or it doesn't really matter. Then the next thing is knowledge presentation, visualization, knowledge presentation techniques. I used to present my knowledge to users. So this is very important. After all of the hard work, your knowledge must be presentable or it must be represented. People must understand what you have done. So at times we show somebody a machine learning algorithm and tell the person maybe you had an accuracy score of maybe 25%, or let's say 80%, for instance. A layman might be like, oh, your employer, if you are not doing it yourself, or if you are not doing it for yourself, your employer might be like, okay, how does that help me? But when your result is visualized, it's represented maybe in graphs, bar charts, histograms, and scatter diagrams, regression lines, and all of that. Okay, people can understand. Okay, they can look, just by looking at your graph, they can tell there's a trend that, okay, we can see that the graph, maybe your line graph, is moving upwards towards the right. People usually signify it's more like a positive correlation, or it is leftward, or maybe you have a curve, you have a normal distribution. It doesn't matter. It's just, it is presentable. People can see that, okay, this looks organized, this is understandable. So when you tell them that this increased with this from the graph, they understand that, all right, it's saying the truth. Or you have a bar chart and you're telling them that the lowest number was at this point, and they can see it from the bar chart there, okay? It's true, the lowest number was at this point, the highest frequency was at this point. So visualization helps what you are doing to be understandable to other people apart from you, which is actually the main goal of everything, that what you are presenting is understandable, it is reasonable to other people. So yeah, so this is a short description in image. So you have the data, the raw data, you have the selected data, the adjusted data, which is pre-processing. So that's like data cleaning and data integration. The next step is to transform the data. You need to adjust the data for maybe scale it up together in a particular range and all of that. Then mine the data, gets the pattern, then evaluate the pattern, then interpret, give a visualization of what you are doing, of what you have done. So the next thing is some techniques that are, some techniques that are important to data mining. So the first one is statistics. So yeah, so statistics is very vital when it comes to data mining, especially when you are going to be doing predictions and interpretations of what you are doing. Now, statistics is basically used by everybody, even though some people don't know what they do is statistics. So a layman, for instance, maybe someone in a restaurant, like for instance, does not know, maybe someone that maybe doesn't have much educational knowledge, just notices that maybe when the person started adding a particular ingredients to maybe his or her jollof rice, for instance, noticed that she had more customers, people were buying more in quantity, and she was making money. Then the next thing she could conclude was, okay, 2 years ago or 3 weeks back, I wasn't adding these ingredients. And now I'm adding this ingredient and I'm having more customers. What do I have to do? I basically need to purchase more of these ingredients and make use of it more often. more often than before. So someone that has statistical knowledge will probably tell you, okay, there was a positive correlation between the use of positive correlation in using Maggie more than no, for instance, or I think people prefer no, for instance. So just like that, statistics comes into play. So someone that is doing data mining or a data scientist, you need statistical knowledge, because at times just by having statistical knowledge, just looking at the data, you have an idea of what you want to do. You have an idea of, okay, look at everything. Okay, this should be my dependent variable and this should be my independent variable. Just by looking. But someone without that, maybe you have to read and read and read and read and read and read. It still boils down to you learning statistics. Or you can tell, okay, this is a normal distribution. It is distributed evenly. Is how I should approach this problem. Or okay, just with statistics, you should know that, okay, I can ignore the missing values or I can't ignore the missing values. Just like that. So statistics helps a lot. It helps a lot. It helps you approach a problem much better than someone that does not have so much understanding of statistical knowledge. So it is not avoidable. Another thing is machine learning in recognizing patterns. So at times, as a person, when you are working with data, you don't understand statistics and all of that, you might not be able to maybe detect a pattern even by yourself. At times, data can look like that. But when you apply a machine learning algorithm, it just automatically booms and you're like, okay, yeah, that's true. I can actually see that there's a pattern here. So machine learning algorithms help you. Like many people have talked about machine learning algorithms in KD, so they will tell you there are systems or machines that can learn from data. So when you feed data into the algorithm can tell, okay, there is a trend. It is likely that this is increasing because of this, and this is not increasing because of that. You understand? So those things help to play. So there are a lot of other things, techniques that are important in data mining, but I think this so stands out. Some challenges you might face. Some challenges you might face with data mining. One thing is methodology. Now, at times, because of variation in terms of how data is stored or how data is received by maybe a data scientist or a data analyst, for instance, or maybe where you are getting the data from itself, how it was passed into the database, how it was or how it was even created. So at times, those variations make things a little bit complicated. So at times, a particular approach you've used in getting data or you've used in maybe cleaning or transforming data might not be so helpful in another data set. So for instance, let's use a very simple instance in scraping data, for instance, when you're trying to scrape information from a website. So now there are a lot of tools available. So we have Scrapy, we have Selenium, we have Beautiful Soup, Mechanical Soup. For instance, so in some sites, when it comes to clicking and all of that, Selenium is great, for instance, and Beautiful Soup, not so great. You actually have to write a lot of code to actually simulate the same process. Whereas with Selenium, you just have to understand it, have a button passing the class and all of that, then it will click that for you, probably in a line or 2 lines of code in most cases. So at times, using Beautiful Soup for that kind of process can be frustrating. And for someone that does not know anything about Selenium, it makes your work unnecessarily hard. So you spend a lot of time in trying to get that information, whereas someone with Selenium would have probably been able to do that better. And sometimes when you're trying to scrape data, Selenium is not so great, for instance. So that's just a simple illustration. So at times, methodology can be a constraint. So at times, to work with some kind of data is quite stressful, especially maybe when you are not exposed to other approaches or tools that could have made things easier. And the good thing is that more tools are coming up to help you with data. So one thing a data analyst or a data scientist do is to always try to keep himself updated. Okay, there's a new tool out there. Okay, this works best for this works best for that. Second thing that might be a challenge for data scientists is interactiveness. So after you've carried out all your information. Whatever you've shown should be interactive and understandable. Now, most times, okay, a positive correlation and a negative correlation might be easier to understand, but you should be able to even present something that has no relationship at all. When you are trying to tell someone that, okay, there's no relationship between these two variables, it should be presentable in a way that is actually still understandable if you've done that well. So at times, constraints comes with interactiveness. At times, you might not, people, if you are not well versed or you are not well knowledgeable, or maybe about statistics, for instance, it might not be easy for you to present your data in a very user-friendly way. So for instance, you are showing someone that is not really exposed to statistics per se, and maybe after doing everything, you now presented him with a scatter plot. And immediately the person looks at it, is just saying dots, 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 and like, how does this help me understand what you're doing? Because so at times you might have to maybe change to a bar chart or a pie chart. At times it just depends, and sometimes a scatter plot might be the best option you have. So those things can act as a constraint. So sometimes you have to spend a lot of time trying to explain. So we should always try to have your data or whatever information you have properly visualized in an understandable way. So lastly, data mining should be applied, taking into consideration various factors such as the cost of extracting information and pattern from databases. So at times the cost of getting information and maybe from a database might not be so easy. That you may have to spend money, maybe electricity and power, time, and all of that. And complex algorithms at times require expert resources or expert people to make use of. So those things should be in consideration when you are deciding to mine data. So if you want to, sometimes you have to pay maybe for some algorithms, or the time you will actually get involved with in building an algorithm that actually make it predict from whatever data you have might be not be so great, for instance. So the type of information too also matters. At times, if you are using historical data, maybe data from 10, 20 years back, and you want to use that to make a prediction of something that is happening now, it might not be so good. So let's say you want to build a social media website, you want to take into features people like, or that gets people. You obviously want to look at how social media has probably been maybe in the last 5 years or 6 years, but you don't want to check from 20 years back. You probably might not get so much information unless you are just trying to observe a trend. But maybe you just took a data from 10 years ago and you're trying to build the social media website currently, it might not look so great. You probably won't make a lot of sales. But if you're looking at something more recent, something more available to people now, generational trends, then yeah, it might work for you. So those are the few challenges you can get with data mining. But the good thing is that there are a lot of solutions, workarounds around many of these challenges that helps people. For instance, a lot of methods are available when it comes to accessing data. A lot of visualization libraries are available, Matplotlib, Seaborn. I know for Python, majorly Pandas, OpenCV might help too at times, and all of that. Then for algorithms, there are a lot of algorithms when they are available. There are even some free APIs, machine learning algorithms also that are free and available for people that can handle a lot of complex information. And for information getting or information sources, there are a lot of databases that helps with getting data sets. Kaggle, for instance, you can get a whole lot of data sets on Kaggle if you're just maybe trying to learn. So it helps in that way. There are people that source for information for people, and maybe they sell them at reasonable prices. So you can get all of that. So you can get recent information quite easily compared to maybe the last 5 years. So with that, I think we can always find a workaround around some of these problems. So yeah, thank you.
No, thank you. It was a wonderful presentation. Thank you. I do have some questions too.
can't hear Mr.
We can't hear Patrick, but can I ask my question?
Mr. Patrick, we can't hear you.
Patrick, are you talking? I'm not sure he's talking.
So you can officially not hear me.
I can
I
hear
think
you.
he said you should go ahead. Say you should go ahead on the chat box.
I can ask my question.
Yes, that was say you should go ahead.
Oh, I tell you then. Okay, so you talked about because I love everything I hear when it comes to data science, but you talked about statistics, which is one of my big fear. But the way you put the statistics is it sounded like normally when we're learning statistics in school, you'll be hearing this one is your constant A. It's really, really confusing. So in data science, is it that the statistic is something that we can see that this relates to? This is something, how do I explain it now? Like it's something that, oh Jesus, English. Like when you were using the Maggie example to explain, and then you were saying that okay, because you put one, I can't remember the analogy you gave, but you get what I'm trying to ask.
Yeah, I get what you're saying. So what I was trying to paint there was we make use of some kind of statistical knowledge or some kind of statistical intuition on our day-to-day basis. You understand? So sometimes you discover that adding more Maggi to a particular kind of food makes the food better. You understand? So to a statistics person or a statistician, if that English is correct, he would probably put it in a different manner. You understand? Maybe do a research over the amount of Maggi people use in cooking their ingredients. Then, okay, find a trend. Does sweetness or deliciousness trend with the amount of Maggi that is present in that food? Do you understand?
Yes, I understand. Thank you so much.
So, yeah. So what I'm now trying to say is that statistics helps a lot when it comes to data science. So, but the truth is, in real life situations or the kind of jobs data scientists do, the kind of statistics you need is not maybe Maggi and all of that. You probably need something more complicated, more labor. But when you are presenting that information to people, maybe in a chat, people should be able to read it and understand, just like when you are telling them Maggi equal to more sweetness. You understand? It should be that clear to people. So
but basically, the statistics is relatable. You can understand it and saying that A is constant. This one, okay. Thank you. Thank you.
All right. Thank you, Mr. Wisdom. I have a question as well. So my question is, I'm a PM and I'm a pro manager, so I really want to know when it's come to role. Sometimes, let's say assume I'm running a project or have a particular feature I want to work on, and it requires some knowledge or some expertise of data scientists or data analysis. So it's something I used to, hear a lot of times that there's data science, there's data analysis. Now you mentioned algorithm the other time too. So let's say imagine I have maybe this is a company that we deal with. Maybe we are selling Pampers to people. We understand, and we're having some record in terms of getting people. Is it like I need a data scientist, to come with an algorithm whereby we'll be using to get maybe to kind of get the record or get people that are most likely going to buy the Pampers. Is it data scientist I'm going to need to work on that algorithm? Or more like how do I even call it? A method of getting those data so that we can actually get people that really want our products or people that actually go for the alternative product, something like that. Then maybe after getting the data scientist, then I need to get a data analyst to analyze those particular data so that it can help me to make my informed decision this time. Or a data scientist can actually do the work of data analysis. So that is my question.
Oh, all right. Okay, so the thing is, data science itself is a broad term. You understand? So when you mention maybe data science itself, you might be talking about a whole lot of things. But for what you are describing, for instance, I would say that is the job of someone that is a data analyst. So basically what a data analyst do is they analyze data for people and maybe interpret that information to you. Do you understand? So someone that is maybe a data scientist so data analysis might be you can say data analysis is under the data science field. You can also say machine learning is also under the data analysis field. So a machine learning person may not be looking to do data analysis, but he might be capable of doing it. Do you understand? So, hello? So the kind of maybe person you want to go for, describing what you said, is a data analyst. Someone that will sit down and with that information and be able to interpret the data for you. Maybe can tell you that, okay, people get more pampers based on this, or people got more pampers, or more pampers when this was done, and all of that. You get.
All right. Thank you for that. I appreciate it. Thank you.
Yeah. Okay. Am I on now? Am I audible now?
Yes, you are, sir.
Am I?
Yes, sir, you are.
Okay. Thank you very much, Idris, for the wonderful presentation.
Yes, sir.
So,